The focus of this lesson is on graphing by transformations. In particular, we're going to talk about graphing by using shifts, or another term for that is translations. And so we're going to start off with what we would call our parent function, and that may be named differently according to your textbook, but that's what I like to call it because it's our starting point. So with our parent function, we're going to graph like we typically would. We're going to graph point by point. So you want to pick x values that allow you to get the general shape of the graph. So since I'm dealing with a square root function, I know I need to pick 0 and above, and then I'm going to pick perfect squares. So I pick 0, 4, and 9. The square root of 0 is 0, square root of 4 is 2, and the square root of 9 is 3. And then what I would do with this is I would just go and graph it. So the ordered pair is 0, 0, 4, 2, and then 9, 3. And then I know that those points could continue on in the positive direction, and so I get the square root function's general shape. So that's just graphing in general, point by point. But now I want to get into the concept of using transformations to graph my remaining 4 graphs that I'm going to be working with. And the first one is g of x equals the square root of x plus 2. And what I want you to observe about this graph is that it also has the same framework. We're dealing with the square root of x. So if you think about that, that square root of x piece is our f of x. And what are we doing to our f of x? We're adding 2. So whenever you add or subtract to your f of x, your original parent function, and I always call it adding or subtracting to your y's, if you will, then that's a vertical shift. So since it's a plus, it's going to be up 2 units. And so the concept of graphing by transformations is you just take whatever your parent function was and you apply the transformation that you came up with, in this case would be going up 2 units. And so you don't have to create that t-chart each time. And so you can see in red here that we have the graph of g of x. In black we have the graph of f of x. So I'll just kind of label it just so it makes sense to us later. And then let's go ahead and move on to a different translation or transformation. So we have h of x, but notice again we have the square root of x, but this time we are minusing 2 to that whole square root of x. Well, the square root of x again is our f of x, and what are we doing to our f of x? We're subtracting 2 from it. So we're subtracting 2 from the y values. So again, that's a vertical concept if you're adding or subtracting to the y values, and since it's minus, it's going to be down 2 units. So whatever our parent function was, which was in black, we're going to take all of those points, even the ones that aren't labeled, if you will, they're all shifting down 2 units. And that gives us our graph of h of x. Now, moving on to the next 2 examples, notice you're still using the same framework for these functions. You're still dealing with the square root, but you're not taking the square root of x. You're doing it where there's something added or subtracted to that x. So that's similar to your original function, but not quite. So it's your original function, but it's evaluated not at x, but in this case at x plus 2. So notice you're adding 2 units to the x value. Well, in that case, it's a horizontal movement as opposed to vertical. And since it's plus, according to your chart, that tells you that you move left. And then it's left 2 units. So whatever your parent function was, you go to the left 2 units. And then go ahead and connect your points. And that is your k of x function. And then last but not least, we have our m of x over here. Again, notice that m of x is in terms of that parent function. You have a square root function, but instead of the square root of x, again, it's altered. So instead of having the square root of x, you have the square root of x minus 2. So is your function evaluated at x minus 2? So you're subtracting 2, as you can see, from the x's. So that's a horizontal movement. And since it's subtraction, it's going to be right, and then it's 2 units. So take your original function in black here and go to the right 2 units. Connect your points, and you have your horizontal shift to the right 2 units for m of x. So that completes this lesson on translations or shifts. Notice again that basically the process is you start off with your parent function and ask yourself, how is it altered? If you're adding or subtracting to the entire function or the y's, then it's going to be a vertical shift. If you're adding or subtracting to the x's, then it's going to be a horizontal shift. And then whether it's adding or subtracting will tell you to go up or down. And then in the case of horizontal, it'd be left versus right, respectively.